Hello my friends and welcome to FISHTORY. I'm Alexander Williamson and this is an audio-friendly episode, so feel free to sit back, relax, and listen while you do your water changes or while you're on your way to work or walking or whatever it is that you want to do that doesn't require watching the screen. In the true tradition of FISHTORY, ! We are on episode number 217. Thank you so much for allowing this to continue so long, for years and years. And these are small stories, usually 5 to 20 minutes, about new and cutting-edge things going on in the world of freshwater and saltwater science. Basically the world of fish and fish tangential things, the aquarium hobby, and everything we love involved with that, from ecology to biology to archaeology and, you know, how humans interact with it. So, thanks to your support, your help, and your continued viewership, we are able to do these. And if you want to become a member of the channel for $1.99, you can, and you can get access to over 216 of these episodes right here that the public does not have access to all of. So here are today's topics. Let's jump right in. First of all, I want to bring you a story about teeth. Yes, and teeth are something I hold near and dear because I don't have any of my own anymore. As you may know, if you've followed this channel for some time, I had a little misfortune with some lightning, and it ended up busting 19 of my teeth, and now I don't have any of my own. I have implants down here, and I'm working on them up here, but they're pricey, and they come for a high price for a good reason. It's because we need them, and you can't live with them. You can't live with it. Well, actually, yeah, you can live with them, and you should. You should live with them. That's the moral of the story here. Just keep your teeth. And evolution, it turns out, has evolved teeth for us in a very crazy way. And there's been this theory about teeth for quite some time, over 200 years as it turns out, of how did they evolve. And we've been looking to our fishy fossil friends to try to figure this out, because, you know, all things that have arms and legs and a head and two eyes and a spine and a vertebrae, you know, they are tetrapods is what they're known as, and they came from fish. Well, when we go back to that common ancestor, turns out that fish are the things that first developed teeth. And then some things came out of the water and stuck with that game plan, and others lost it. Others had that game plan, then lost it, then got it back. And there's also some other creative things that have happened along the way too that we can talk about another time. But it turns out that brand new research out of Denmark has turned up some really interesting new information about teeth. And we have been wondering, as a evolutionary science community, that's all of us, we're all wondering, we're all standing here wondering, what did these teeth look like early on? And the thought was, you know, were they originally some sort of like defensive thing, like horns, or that like stuck out on the face, or that were like, you know, maybe tusks or something like that, and then they worked their way into the mouth? Because we know for a fact that both feeding with a beak, or rather a sharp edge that goes all the way across, or two little mouthpieces that come together like a jaw, have been a pretty good game plan for a long time. But we're wondering, did the teeth come and did they kind of migrate to the jaw, or did they start as part of a beak that then got kind of split up, and it's the beak that got split up? And so there's the outside in, which is the idea that the teeth started somewhere on the outside. The other idea early on was that shark scales look a lot like the teeth that a lot of creatures have, like, for instance, pigs. They have this same pattern that you see over and over, which is the idea that there's one big triangular spike in the center, and it kind of sits amongst either a lower spike to the left and to the right of it, or to the back and to the front of it if it's in your mouth. And there's kind of this three-peak mountaintop triangular thing that is seen over and over. And over time, that evolved into the molars we know, where that center spike either gets worn down or shifted back, and we see kind of a tabletop of 4 little spikes instead of those 2 with the big one in the center. That center one moves either back or forward. If it moves forward, it becomes a canine evolutionarily, usually, like one big sharp tooth. And it tends to then look like fish teeth that we see in the fossil record, like things like shark teeth that are one big wicked kind of tooth, or a T-Rex tooth, if you want to think of it as kind of one tusk-looking tooth. And they've wondered, did these teeth, like I said, form on the inside from a beak, or from teeth that got more and more complex, or bones that got more and more complex, or did they form, from the outside in as scales or as horns, in that way? And there's been some debate about this, and it was a grad student that was wanting to do a meta-analysis, which is when you take lots of research and you look at it all together and you think, what does it all mean? And you put together all the fossils that you can on a specific subject. And there was a grad student who did so, and basically she put together over 150 fossils of fish that she thought might be related to the first true teeth, the first independent toothed fish. And she actually ended up with an amphipod as well, which is not a tetrapod if you're paying attention to evolution and biology and taxonomy. That is more like a roly-poly bug, or, crustaceans, or crabs and lobsters and shrimps and things like that. More like an insect or one of those. And yet, there are those that have teeth as well. And the thought was, well, they both have teeth. Maybe they go farther back than that even. Maybe they go way, way back. But it turns out, no. Teeth have just evolved numerous times in different ways. And it turns out by using CT scans or computed tomography that we are able to then look inside of these early fossils with never before seen resolution. So we were able to look at fossils that have been sitting in jars or slabs of rock on shelves, and as samples of also biological living fish, as well as fish that are deceased that are samples, and compare teeth across all these things. And what do teeth have in common? Well, they all have a nerve and a soft center, and then they have what's called dentin around that. And the dentin tends to have a blood flow to it, and then there's either enamel or bone or keratin or something that is non-organic, generally speaking, in the sense that it forms from cells in the body. It builds outward in layers, like eggshell layers being layered on top of each other. And then once it's laid down, those cells die, and you have either that tooth for the rest of its life or your life. Now, some animals will create more teeth throughout their life, and they will come forward, just like we do with our baby teeth. Well, sharks are able to do this over and over. And it is this specific biology of the tooth that kind of stands out as, okay, well, maybe the teeth we have are something special in that they have that nerve, they have that dentin, which is the softer or living tissue, the pulp, as it were, of a tooth, in the center of the tooth, and then it's surrounded by a hard enamel, or, some sort of hard surface that's no longer living. And yet, we are creating this with the food we eat, or with the food that our parents ate, and then we develop as embryos and then as little organisms, whatever species you may be, a fish or a human, and you somehow are making a mineral in your teeth that is strong enough to eat almost like rocks. Can eat, in many cases they can eat bones. So how is it that they make such a strong thing out of organic stuff that you can eat? You have to be able to eat it and consume it to then rearrange the atoms and create it, right? So it's a pretty interesting process that we could get into, and we could do a whole episode on fish teeth, or teeth in general, if you're curious. But it turns out that early on, around 450 million years ago, there were these sensory organs on sharks and other fish, and specifically on their forebears around 500 to 450 million years ago, before sharks and the bony fish, or kind of the fish that we keep in our aquariums generally, and everything else, armored fish, catfish, those things branched off, that we see almost this kind of stingray-like creature that's a flattened fish that has these kind of horns on it. And we call those oftentimes denticles. And that is when they just have that bony protrusion, just that enamel, or just that sharp spot. And it turns out that it appears that shark scales are closer to that. They're closer to, evolutionarily, it's appearing now by looking at all these fossils, that it looks like those are more of something that forms, and that it is then in place, and it is like keratin, or it is these various hard substances that we create in organic creatures that then get layered, and then they kind of turn into scales. Well, it turns out that the difference between those denticles that are sharp things on the outside and teeth that are on the outside, well, there's something similar to those hardened rocks or horns, or whatever you want to call those little bony protrusions that are on a lot of early fish. If you look at sturgeon and things, they've got all these bony rays all over their face and down their side. And when we were looking at these things, and by we, I mean that grad student, it turns out that they weren't all just bony protrusions that came from, living tissue and then were kind of inorganic after the fact, but rather there were quite a few that had sensory cells in them. So a nerve or a whisker or some sort of thing. And in fish, we call this thing an onodontode. Think of your catfish or your plecos. They have these little barbs or barbels, or onodontodes as they're called, and they are able to smell, taste, sense, feel vibrations, and so forth. And it is for that reason that our teeth are able to feel. So if you ever bit on something and then you feel that jarring pain, like chew on aluminum foil, don't even tell me about that. But that zing it sends down your tooth. Or if you ever got something really cold on your tooth, why in the heck would we have this sort of inanimate, hard, rock-like object in our mouths? Why does it need to feel? Well, it's a leftover advantage, possibly, to tell us when we're going to damage our teeth. But moreover, it's just an artifact of the fact that these things came from all the whiskers and barbels and little sensory organs that were all over these early fish and early proto-fish, and all the tetrapods kept this. Now, other things like dinosaurs that became tetrapods and things, they may have evolved beaks again, and in some cases the beaks then have nerves in them. They evolved from these teeth. Or they may have two pieces of a beak that are really just two giant teeth. Or they may have horns or different things. But now we know the difference between what a horn is that's around a bony core, like an antelope or a gazelle that has that, and then they have keratin around that forms and is organic, and they lose it. If it's an antler, they lose it. If it's a horn, it stays, and it's a big sheath that is formed in layers over time. If it is something with nerves and a soft pulp in the center, it's technically a tooth or an onodontode. And if it's something that is just bony, then it is a denticle or a dentine like substance that's formed into another, whether you want to call it a horn or a bony protrusion or whatever, a cusp. There's lots of words for these things if they're attached to bone versus if they're, on their own. But pretty cool that now we know where teeth came from, and we know that we evolved them from the same place that fish did, even if some of the critters later gained them and lost them and adapted them. And now we see all sorts of really crazy adaptations where these sensory things, some became the entire sensory system of fish down their side, you know, with all sorts of pressure detection, all sorts of heat detection. And it's likely heat, hot and cold, and pressure that our teeth first evolved to sense as those whiskers. And then they kept that ability as they moved into the mouth and became harder and harder and used for eating. So that's the bummer of why you can get essentially a brain freeze from the nerves in your teeth and in the back of your throat as well, the nerves there. And you can blame your inner fish. So, thought that was an interesting story, and I hope you do too. We got one more story for you today, so let me tell you about that one as well. This one is a little cuter in that it's about clownfish and the ability they have to shrink in order to save themselves from heat. So, a recent study was done in the South Pacific, specifically off the coast of Papua New Guinea. And it turns out that the adorable little Nemo clownfish, we knew it had the ability to do some pretty crazy things. We knew that they had the ability to transform at a whim, whether that be hormonal or that be a trigger in the environment. We knew that they're all born male and that then some of them turn female. In fact, the biggest male will become the female of the group when the female in the sea anemone or in the little colony they live in or in a pair they live in no longer ceases to live. And all of a sudden, the next biggest male will start going through basically a form of what's an extreme form of puberty and actually starts carrying, you know, the cells for reproduction, eggs and everything. So it's pretty wild. We knew that they could do that, and that's been known for a long time, and it turns out many fish can do this. Now we're learning. Some do it in only extreme conditions. Some do it in like an average setting that's just normal for them. But it's a pretty incredible thing that they're able to do. And so we wondered what else can they do. And so we've been studying these clownfish in order to just understand what all can they do. Well, it turns out we knew that they could grow really fast like that to become a big female and a dominant sea anemone. Well, we knew they also grow to the size of their sea anemone. So if they find a sea anemone that's too big for them and they don't nest into it just right as a pair and with their babies and all, they'll actually lose bone density and mass to fit that sea anemone. And also, they'll grow at 2 or 3 times the rate that they normally grow to fill it out if they find a big sea anemone, which is all new to me. I didn't know this, but that's pretty cool. Maybe you knew that already. And it turns out that they are adapting to warm oceans in a way that's very novel, and it is that they are shrinking. So this was not at all the goal of the research. This was not at all the plan to study these fish and find out how much they're shrinking, right? We wanted to document if some either grew or shrank and if that had a correlation to sea anemones. And by we, yet again, not me. I'm not off the coast of Papua New Guinea diving in shark and jellyfish infested waters in the most remote places in the world. So thank you to the scientists who did, so I can stand here in comfort in Seattle and yammer on about it to you at your place of comfort, or maybe discomfort if you're headed to work or doing a real nasty water change. But these little guys, it turns out, after they were monitoring them on the moon cycles, they were monitoring them on the moon cycles because coral reefs change by the moon in large part, and then by major seasonal shifts like the wet season and dry season, or the hot and cold season, depending on how far you are from the equator. Well, these guys are right on the equator, and it turns out that the moon cycles are what change things, right? That's kind of like their phase calendar. And so that's when we measure them, because with the new moon, you may have new babies. With the new moon, they may have a new female in the group. And it turns out that they may shrink if it's been hot. And so in quarters or moon phases, really, where it was hot, they found that 78% of the fish survived heat waves that they normally wouldn't, and that the fish that survived were about 76% of them that survived were the fish that shrank. And they're like, what? Why did they shrink? So they're looking at them and they're thinking, these fish shouldn't even be alive. And then they're thinking, wait, we measured these same fish at these sea anemones that they live at. They live at one place. They have an address. And they go and they geotag that. And then they come back and they check. And they found that not only did they survive, but they shrunk a little. And you're wondering, how much did they shrink? Did they shrink down from, a golf ball size to a grape? No. They only shrunk at most around 12%, which is a lot. That was the max. Most of them only shrunk 2 to 5%. But that shrinking of 2 to 5% for as long as the heat wave lasted, each of those cycles, added up to around 5% in the case of over 50% of them. And that is actually quite a bit. That's statistically significant. And it turns out, like I said, that they survived at a 78% higher rate than the fish that did not shrink. Because some of the fish just stayed the course, did their own thing, and maybe they were vying to be a big female, maybe they were next in line for the throne kind of thing. And the other ones, were just kind of nowhere in line of inheritance, and they figured, all right, I'm going the other way. I'm going to get smaller. I don't want to be in line to be the alpha female of this group, and I'm going to get smaller. And it turns out that's a good plan. But now they got to figure out why and what exactly is going on. But they realize these fish are actually absorbing bone. They're actually getting shorter, skinnier, and less dense. They're getting smaller in every way, which is pretty weird. They're not just losing weight or, shedding some extra pounds and some extra water weight. They're shrinking, which is really wild. And if we didn't know that they were little changelings already, it would be quite shocking, even though it is still pretty shocking. Boy, I made that anticlimactic. Well, all right, you guys, those are the 2 episodes of FISHTORY for today. Hope you enjoyed them. News from the fish world. I can't do this without you, so thank you so much for being here. Please share with someone who would get a kick out of this. YouTube never treats these well. And if you ended up making it all the way to the end, maybe a little cat icon or a smiley face or something to let me know you made it all the way through, that you're a trooper. Helps me look at those analytics and think, all right, those are my diehard crew right there. That's who's going to win the sweepstakes. Wink, wink, nudge, nudge. Next time we give something away. All right, you guys, have a wonderful day and take care. Bye.